So today I want to give you the introduction for our S6200 anesthesia system. And this video is for the operation and the introduction for each accessories and also the machine functions. So first, I would like to introduce you about the assembly and the spare parts for this machine. The first part of this machine here is the anesthesia ventilator, and also with the big screen, which this model we are using the 15-inch touch screen. And here is the ventilator position, which usually we can handle on two different colors and different medicine with the anesthetic medicine and ventilator speed. And thirdly, we can see here the dressing circuit. And for this one, we are using the metal one, and also it has the heating function and also the bypass function. Here is the drawers. For this machine, the standard configuration is 3 drawers, and which each one of it actually can put in different kind of things. Then here is the trolley with the brakes, and this one we're using the central brakes, which actually pipe it down, and the machine is very steady, it cannot be moved. Also here, by the side of the machine, if you order requirement to have it, then we will give the hanger for the patient monitor as well, by here. By the back side here, we will give the high pressure breathing pipe, the gas high pressure pipe, the power line, and if you order have the requirement, we will also give the yoke. And we can give 1 gas with each yoke. Okay, now I will start the introduction for the machine functions. First, we will start on the machine by this button. Once we open the machine, we can see the self-testing, and it only needs about 3 seconds. Then we will get into the main self-testing interface. By here, we can see the different kinds for the different checking. For example, like the inspired flow sensor, aspiration flow sensor, pressure sensor, lung compliance, airway resistance, and airway leakage, and expiration valve check, and oxygen sensor check. So if all of the check is finished and the machine has no problem, actually here it will show us. And if any of them has problem, it will also be shown here. Then we will have the different solutions to solve the problems. And if sometime, for example, the operation actually is very urgent, and we think the machine has no any problem, we can also press the standby, then to get into the running function directly. So by the standby interface here, we can see, here we can choose the new patient and the last patient. By the last patient, it means we can directly start the ventilation with the previous preserved ventilation modes and parameters for the last patient. So it's very quickly and fast. If you are using for a new patient, then here we can choose for the patient type first. We can see this machine we can use for adult, pediatric, and also newborn babies. That means the neonatal. So we choose newborn, for example. After we choose it, here we can make the parameter settings by here. Then we can see the different ventilation mode. Here we have the VCMV, AC, SMV, PCV, PSV, manual, and spontaneous. And under the VCMV, we can check here for the tidal volume. Once we're getting higher of the IE ratio, and also we're getting higher of the frequency, then we can realize to make the tidal volume at lowest by only 5. That means the setting range of the tidal volume for this machine is from 5 to 1500 milliliters. So it can use for newborn baby to adult. After all of the settings here, we can press confirm button. Then we will get into the interface for the machine, already starting the ventilation to the patient. So by the main interface here, we can see we have 4 versions. The first is the above side. It's about the alarming functions, which can show us the alarms here. And we can see there are totally 2 colors, the red one and the yellow one. The red color means the first level, yellow one means the second level. The red one is always the problem we must immediately solve. For example, now you can check in the oxygen supply low, or maybe the airway pressure is very low. That means the machine now, because we're not connecting with the gas source, so it will show here. Then after we connect it, then it will disappear. And for the yellow one, we will check. Sometimes it only shows the battery, maybe the AC power failure, then at least our machine still have the battery inside for running the machine at least for another 3 hours. And if you're adding another battery, then it can running at least for 6 hours. So you don't worry about it. And also by the upper side, by the alarming function area, we can also see the ventilation mode we are choosing now. The patient type we are choosing now is for reminding doctors if they already setting the correct parameters. And by the right side here, actually we are showing about the time, the battery status, and also if we are using the heating functions now or not. And then by the middle side, the second area is the biggest part. We call it the waveform or oscillograph area. So here we can see, for this oscillograph, there are 1, 2, 3. Actually, we have 3 waveforms and also 1, 2, 3, and 3 loops. That means 3 waveforms and 3 loops to be synchronous shown on the big screen. That the doctors, someone, they may prefer to see the waveforms. Some doctors, they may prefer to see the loops. Then we're getting all of them together. So you can just check and also do some preparation and comparison. Then we check about the third version. It's about here. Actually, it's the adjusting parameters. All of this data should be same like the presetting interface. That means what we have just said, it will be also shown here for the doctors to check in again if they have already do the correct selections. And then the last part will be the right side. And for the right side here is for the monitoring parameters. Actually, all of the parameters from this side is coming from the patient end. It means the doctors can tell him if the patient is healthy or not, is he using the machine good or not, they can be telling by the monitoring parameters here. So here we have the milliliter volume, oxygen concentration, peak pressure, breathing frequency, PEEP, lung compliance, EtCO2, and IE ratio. And for this machine, because it's the high-end machine, so except for the 4 versions which I have just mentioned, we also have the left side here. Because this machine actually, we have the electronic flow meters and also the AG module monitoring can be shown on the screen. So here, for example here, the first column is for the electric shoes for the inlet pressure. We know for the machine here, we already have the mechanical pressure gauge, but for extremely accurate, then we also have the electronically gauge shown like here. So it will be much easier for doctors to know if the inlet pressure of the gas is enough for the patient to use or running the machine. Then by the second column here, we can see here for the EtCO2, nitrous oxide, and the agent 1, agent 2, and also the MAC. So this part is for the anesthetic gas module. So if the doctors want to check the anesthetic module from the patient side, actually when they buy the sensor to equip with our machine, then all of the data will be shown by here. And then the last part here is for the flow meter. Except for the mechanical flow meter, then by the screen side we also have the electronic one. So for this machine also we are using the electronic PEEP. So the adjusting for the PEEP and for all of the parameters will be much more accurate. So that's why this machine is a high-end machine. And for the flow meter here, how can we set it? We can just set it by this. To setting for the oxygen concentration and setting for the total flow, then actually all of the flow will be separate here automatically. Okay, so this is for the range for the screen size, and now I will emphasize about the functions. So first here we can see this button. This button is for freeze. Once we press it, we can see the screen actually is freeze. And now we can take some screenshot for the doctors and nurse to know exactly the patient situation. For example, if the patient is using an anesthesia machine, but in a second we find that the situation is not good, actually we can freeze the screen and then we take a screenshot for our later research and to know how we can make the patient better. Once we press it again, the machine will run again and the waveform is going on. The second button is for the settings. Here the first column is for the graphic settings. Here we can shut down the loops, for example. If we turn it off, then by the screen, we will only see the 3 waveforms. And by the loops area, it will show all of the data and parameters. For example, like the mean pressure and the platform pressure and PIF, PEEP, and also RI and RSBR, and also even the inspiration tidal volume. And also, for the graphics, actually we can change the third one. Now we are showing the EtCO2 and time. we can also change to the volume and time. After we change it, you can see by the third one here, it shows VT. That means volume and time waveforms. For the second column is for the environment setting. Here first is about language. For this one, we already have enough language. For example, like English and also Spanish and also Russian, French, and Chinese. And even you have some other customized language you want, we can also make it in the software for you. Here is for the day and night settings, just like our phone, to protect the user's eyes and also make the screen much more clearly. For example, here we set it up by the light time, then it will change the color like this. And then this one is for the heating function, because this machine, as I have mentioned by the bracing circuit part, it has the heating function for this one, for standard. So if you want to use it, we just turn on software. If you don't want to use it, we just turn off. And turn on, we just rotate the button and put it on, then it will be finished. For the third column here is for the oxygen concentration calibration. We know actually in different countries, the oxygen concentration in the atmosphere is different. There are some very small difference and changes. So before the first time using the machine, or maybe after the first installation of the machine, we need, after we connecting with the air and the oxygen, we need to do one time of the oxygen calibration. Here we have 2 points, the 21% and 100%. Here we can see by the 21%, it shows only imported the air. So now we shut down the oxygen and only connect with air. Then we just press the 21 point, we press it, then it was starting. Now we're not connecting, actually, when you are doing the oxygen calibration, we just follow the note. To switch to the manual mode, we just press it. And only need about 1 minute, it will show finished and okay. And then we will turn to the 100%. And by the 100%, first we shut down the air and only connect with oxygen, pure oxygen. Then we also press it about 40 seconds to 1 minute, it will also show finish. Then actually this step is finished. And then we can exit. For the fourth part here, actually is about the AG module. Because I mentioned to you for this machine, we can connect it with the AG module and show on the screen. So here we can also do some calibrations. For example, here for the oxygen and for the natural skies, and even for the zero calibration, we can just make it by here. For the other settings here, we can see it's just like same interface by the pressing here with the flow meters. So we can set in the oxygen concentration, and usually it's from 21% to 100%, and we can set in about the flow like this. And also we can set in the mixed gas. And also here, we can lock the stations. For example, if we lock it, then all of the parameters we cannot touch. This is only being used when you left the patient only in the patient wards or patient room. And for the data here, we can also check it by the tabular. So it means the graphics, which we can make the comparisons for the oxygen concentration and actually the expiration tidal volume and minute volume. And also here we can choose if you want to do the comparison for 1 minute, or maybe 10 minutes, or 30 minutes, or 60 minutes. For the tabular here is also with the different kind of the events and occurred by the different times. Everything data will be shown here with each of the parameters and the data exactly. And for this one, this column, actually we are setting for the patient information. For example, like the age, and like the weight, like the bed number. So that's, I want to mention to you, this machine we can also connect it with the RS-232 or some hospital information system. So all of the data actually can be transferred to the central station of the hospital. It's very easy for you to control the patient. For the last column is for diagnosis. This is also some advanced parameters and functions for our machine. Usually only occurs in some high-end ventilators, but here we also make it in our anesthesia machine. For example, the first one, the instrument PEEP. And here we have the NIF, that means the negative inspiration force, and also P0.1. So everything can be shown by here. Make it a very high-end mode. Then we can see this button here is for mute button. And once we can see now, because the machine has some alarms shown here, so it always has the visual alarm and also the sound alarm. So if sometimes we think actually the alarm is not very important, we can still using the machine. Then we can just press the mute button to make it keep silence. And after we press it, it will be shown a symbol by here. And it has 2 minutes time counting. And after the time counting, actually the sound will come again to prevent if the doctors forget to turn on it. And if you just want to turn on it again, we just press it again. It's also okay. The last button here is standby. Once we press it, and it will show again to emphasize if you really want to get into the standby mode. Because if you really want to get into the standby mode, then the ventilation will stop. So we only get into the standby interface after the patient using the machine. And after we confirm, then the machine will get to standby. Now the ventilation will stop. And I want to mention again, for this big screen, it's 15 inches, and I just operate, it's a touch screen, and with different colors, so it's very easy and clearly for you to see all of the data here. Without the touch screen here, we also have this button, which you can also rotate and choose anything. So it's prevent if someday the touch screen is not working, at least we can still using the menu buttons to rotate and set, like this. Okay. Now we get to the ventilator side. For the ventilator here, actually it's very easy. Here, by this position, it's unlocked. And it's very easy to put out and get inside. And after we put on the ventilator, and we will rotate this button to lock it, then the ventilator cannot be moved. So here, actually, for the ventilator, we have 4 choices. The halogen, enfluorine, isofluorine, and sevofluorine, which you can choose 2 from them. And some customers, they can also choose 2 same one. It's also okay. It's as per your requirements. And for our ventilator, actually, we have different choices. For example, for the medicine filling, we have the pore filling one, we have the key filling one, we have the easy filling one. So, and even we have the quick fill, so which you can choose. And for the ventilator itself, we have the advantage. We have the temperature, flow, and pressure automatically compensation. Because we know when the gas gets inside of the machine, actually it's a long routines finally to get to the patient end. So actually it will be must have some loss of the parameters. So if we have the automatically compensation of the temperature, flow, and pressure, then it will always ensure the patient get what exactly the doctors want them to get. And also here for the ventilators, we can see it has the self-lock and the zero-lock function, self-lock function. So, for example, the self-lock means if I want to set it, I cannot rotate it directly. I must press the 0 button. Then it's very easy for me to rotate. And usually for the halogen, enfluorine, and isofluorine, the concentration is from 0 to 6%. And once we turn it back to 0, the button will come out and we cannot move it again. Why we have the self-lock? Because sometimes maybe the doctors only using the anesthesia system as a ventilator for ventilation of the patient without the medicine using. So we must ensure there's no any medical accident. And we also have the interlock function for the 2 ventilators together. For example, if I'm using one of it, then this one, even I press the 0 button, I cannot move it. It means the interlock. That means by one time, only one medicine of the anesthetic can be used for the patient. It will not make the medicines to be crossover to get some accident to the patient. And also by the ventilator, we can see by here. Here we have a flow gauge, which we can see the capacity. And if we still have the medicine inside, if the medicine is full, actually, we will see it by here. And if we see actually it's almost empty, then we must open this and to add in some medicines inside. And also here we have this small button. For example, if there are still some medicine left inside of the ventilator, but we know that maybe we have a long time will not use the machine, then we can rotate this one. And then by the bottom side there is a small hole, and the medicine rest inside of the ventilator will be poured on and poured outside, so it can keep the ventilator steady. Then the next time when you're using the ventilator again, we just put in some new medicines. It will be good for the patient and good for using for the ventilators. Now we come to the dressing circuit. For this pressure circuit, actually I have mentioned to you, we are using the metal one. So it has the bypass function and the feeding function already for standard. So first here is for the bellow. And this bellow, you can see, it's from 20 to 1500. But as our tether volume for this one is from 5. So actually you can use from the 5 to 1500 milliliters patient. And it's very easy here to put it down. We just rotate it, and then we can easily take it out. And install it, we just move it, then it will finish. This one is a pressure gauge, it's the total gauge. And usually we can check in by this to know the inlet pressure, but sometimes we only use it, for example, if there is some leakage, we have two choices. As you see by the inspection interface by the software, we already have the leakage test. But if you sometimes you believe the manual test, then we can use this gauge. And if the gauge about the guidance is not getting lower, then it means there is no any leakage. Here are two valves, one for inspection, one for expiration. And also, for this one, we are using a single valve. That means if this one is open, this one must be closed. This one open, this one must be closed. So there also will not have any leakage. And here we can see the symbol. If we turn to left, it will unlock. If we turn right, it will be locked. So it's very easy. Sometimes, for example, if you want to change inside of the ceramic, actually we just rotate it and we take this out and we can change it. This one is the APL valve. The APL valve is being used under the manual ventilation. Once we want to control the maximum pressure, then we can set it. For example, if we set it by 50, then it means when we are using the manual ventilation, when we are press the bags, then the maximum pressure will never beyond 50. It's for keeping the patient very safety. And this one is the exchange button for manual ventilation and mechanical control. Now you can see two symbols. The left side means the bellow, right side means the bag. So now it's on the left side, it means the mechanical control. That means the machine automatically controls the ventilation. And if we want to use the manual ventilation, we just turn by the right side. Then we are using the bags. And also by the screen side here, it will show a symbol. That means now we are using the manual ventilation. And when we are using the manual ventilation, we just connect our bracing bag by here. This one we already have the header for standard. So doctors do not need to turn down their hand. They just stand here and very easy to operate it. And we just press the bag for giving the ventilation to the patient under the manual mode. Here is the instruction port and expansion port. And if you want to clean it, it's also very easy. We can just rotate this and then we can take it out very easily, like this. And also the sensor, we are using the inbuilt design, so it will never broken and we can keep it steady for using it for a long time. And we just install it back, and it's also very easy to rotate it very tightly, then it will be okay. Here, this one is for the oxygen sensor. And if we don't want to use it, we just take this sensor line out. If we want to use it, we just insert. And you must remember, another side, we're always connecting by here with the oxygen symbol. And here we have a small port. We just connect it like this. Then the machine can monitor the oxygen concentration from the patient end. And by the side here, we also have a yellow port. And you can see here it's writing CO2 or AG. It means if you equip it with the ET-CO2 sensor, actually that is the standard configuration. Then connected here, the machine can monitor the ET-CO2 from the patient end. And if you choose the optional design for the AG module, then you connect here, then we can show the anesthetic gas on the screen side. And the anesthetic gas will always including the CO2 monitoring, and also with the natural oxide, and also the vampire concentration, and also the MAC. Here will be the flow meters. As I mentioned to you by the screen side, we already have the electronic flow meters, but here we also have it. So for this one, you can very easy to control it. We can see here is also oxygen and total flow. So that means we can rotate the buttons here for setting, and we can also choose by the software here to show. It's same, oxygen flow, oxygen to the flow. And why here we still have a mechanical one? Because for example, if the machine screen has problem or without the electricity, then still we can use the mechanical flow meters to setting and to know the patient flow by here. And if we want to use the emergency fresh gas, we need to open it. And after we open it, actually the electric one here will not be used and should, and to reminding you now you are using the emergency mechanical one. So then we can just rotate it here to see the flow. Here are the pressure gauges. And I mentioned to you by here on the screen, we have the electric pressure gauge to show the parameters very accurately and directly. But at the same time also, here we have the mechanical one. It's also for prevent if the machine has any problem without the electricity or something, then we can still check it by here. And why we have two columns, here we can see. The first one, the symbol is like a breathing pipeline. So that means the air, natural oxygen, and oxygen here are connecting with the central gas pipe. Then we will check the inlet pressure by here. And here is showing the bottles. So for example, if we are connecting the gas source from the cylinder or the yoke on the back side of the machine, then we will check the inlet pressure by here for air, nitrous oxide, and oxygen. And this one is just the power switch. Now let's check about here. Here we have another port, and it's writing the ACGO. The ACGO means the auxiliary common gas outlet, and it has usually actually four functions. The first function is that after using the anesthesia machine, if the doctors want the patient to be recover very soon, then we can use this port to give the patient pure oxygen, because we know the main pipe already has the anesthetic gas, but here there is only pure oxygen, so the patient can recover very soon. Then the second function is that, for example, sometimes if the patient comes to the hospital very urgently, without have the time to check if they have the infectious disease or not, then we can also use the ACGO port for doing the operation for the patient. Then for the third function is that we can use this port to do the open circuit operation. Usually when we're using the mechanical bracing circuit, we are using the closed circuit or semi-closed or semi-open. But if we want to using the open circuit, then we're also using the ACGO port. Then we're connecting another of the T piece. That means the another side with the two connectors, one side connected with back and one side connected with the mask for putting on the patient face. And the fourth function, the last function is that, for example, if sometime the machine without electricity, then at least we can use the ACGO port to give the patient ventilation. It's also easy to keep the patient very safety and waiting for the electricity coming again. So how to use this function? We just open by here. For example, now it has also two symbols. Here, this one means the mechanical ventilation. And once we want to use the ACGO, we rotate it. Now we are starting using ACGO. The same time also on the screen, it will show ACGO. It's for reminding you now we are using the ACGO and without the mechanical control. By the middle side here, we have another small button. It shows the oxygen plus. Actually, this button is for the rapid oxygen or oxygen flush. And it's usually using, for example, if during the operation we find the patient SpO2 has some problem, it's very low, they need some pure oxygen, then we can press it one time by one time. And every time we press it, it will give a total pure oxygen with the big flow to the patient to help them to recover their SpO2. And the second function for this is that every time before the operation, we can, after the setting of the parameters, we can just press the oxygen button and to make the bellow to the top side of the cover. Then we just lose our fingers. So then it will be making the operation starting very fast. Now let's see the drawers. As I mentioned to you, we have 3 drawers. So that means by different drawers, you can put in on different things. For example, the first one we can put in some accessories. Second one is with some patient information. Third one with some spare parts. And each of the drawers actually is still very big and enough for putting things inside. And also the depth is also good. And lastly here is for the trolley. The trolley actually we have 4 wheels. And for this one, the design is the central brakes. And you can see, now actually the machine is very easy to remove. And once we tighten it down, like this, you can see it's very steady, it cannot be moved. And here by the bracing circuit, we can see we also have the carbon dioxide absorber. And for this one, it's a big one. You can, and also it's very easy for this assembly and assembly. For example, when you rotate it, you can easily take it out to change the sliding. And also for this one, as I mentioned to you, we have the bypass function. So even you take it out, actually you don't need to change to the manual ventilation. You can just start using the machine continuously. And after changing it, you just slide it in like this. It's easy, and then we just rotate it again. So it will be finished. Now, let's see the front side of the machine. So by the back of the machine here, first we can see the auxiliary power socket. So for this one, we have 1, 2, 3, totally 3 for standard that you can connect it with some other items. For example, if you are using the patient monitor, the suction machine, and even some AG monitors, you can all connect the power with our anesthesia machine. So we can make the power line not very steady. Only one power line from the anesthesia machine to be connected with the AC power. Then it will be finished. It's very easy for keep steady. And then here is for the gas source. Here we can see, here is one port for the air, one port for the nitrous oxide, and 2 ports for the oxygen. Because we can see these items here. We have one port by here, one port by here. So why for oxygen we need 2 ports? Because this machine is pneumatical control. So the gas-driven gas actually is oxygen. So the oxygen is the most important gas for anesthesia machine. So here, for example, if we have 2 oxygen sources, for example, one from the cylinder, one from the central oxygen supply, we can connect in one gas source with here, another gas source by here. So that means if one of them is failure, another one can already and automatically to give the oxygen. So we can keep the machine always running without any problems. Here are the yokes. The yoke is the optional function. But here we can see we have oxygen, nitrous oxide, and air, one for each. Totally we can put 3 yokes by here. Then later you can hand in the cylinders in your local countries by here. And the cylinders actually being handed here, it's very easy to be moved with the anesthesia machine together. And here is the fan for giving the heat out. Also, here actually we will put in also on some hospital information systems if you need, and it's also the optional. And also by the design inside of the anesthesia machine, actually we have the separate design for the gas circuit and also the electric circuit. If we open this cover, we will see all of the electric circuit is under here, and all of the gas circuit is under here. That means it's the separate design. So that means the gas pipes, valves, and the electric lines will not cross over. Even later we want to do some maintenance, or actually the machine has any problem, we can very easily find what is the problem and just exchange the dirty parts. We don't need to disassemble many things. So because some customers, they may change the bank running, so to make the machine has any problem. And also right here, lastly here, we have the light. This light actually will be shown with the alarms together. And also by the dark time, or maybe the weather is not good, we want to make the screen much more clearly for doctors to operate, we can open this light. We have the top light here. It's very easy to control. And for the patient monitor, we can hand in by both the left side and also the right side. But also if you don't want it, we can also put it on this, the top side of the anesthesia machine. And here is writing. We can put in at least 20 kilograms by max. And lastly, I want to mention is that about our software. We have a good advantage for the software is that we have all the calibration automatically by the software. And actually we can tell your engineers. For example, after we press this button and switch on the power, we can get into the different calibration by here. For example, like the valve calibration, flow sensor calibration, and the pressure control, the drill pressure, FI2 sensor, even the touch panel with the different points. and everything by here, and even the functional. By function here, we are showing the password, and actually we will tell your engineer about the password, then you can get inside of it, and even you can turn on the heating function, turn off it, and sometimes if you want to demo the machine, we can also set in the demo mode, enter this software. So this will be all of the introduction for this Anesthesia system.